What's up guys, Turbo John here. Today I'm going to talk about something a lot of y'all don't want to talk about again, but it's carburetors. Budget blow-through carburetors is what I'm going to talk about. I'm going to show you how to do a homemade one. I've done it, it worked for years, it works great, but I'm going to show you how to do it. I'm going to show you what all is involved and kind of the theory that is behind how to make a budget blow-through carburetor at home. Let's talk about blow-through carburetors. Started off in the early 2000s, blow-through carbureted. I did my own back in the days when Turbo Forums was Turbo Mustangs. I don't even know if that website exists anymore, but we had a lot of good content, and it was challenging. It was hard, and that's when, you know, the big companies started getting involved and they started making stuff happen. So check this out. I'm gonna show you what I do on a budget blow-through carburetor. Okay guys, so let's start with the basics of a blow-through carburetor. If I was going to make this a blow-through carburetor, the first thing I would do to this carburetor is take the choke off of it, kneel this horn off of it real good, take obviously all the mechanical choke linkage stuff off, all that stuff would come right off, and then I would completely disassemble the carburetor. These are your vent tube extensions, so of course you're going to have your bonnet, you're going to have your carburetor bonnet, it's going to come up and go forward or sideways. From what I found in my experiences, from dealing with blow-through carburetors, it was always better. I had better distribution if I faced the bonnet either forward or backwards. I tried doing it to the side a couple times. I tried doing it this way. And if you think about air, air is a fluid. If you have a short turn, it's going to be more difficult to make it the air turn here, and then it's going to go more stack up to the back. Now, some of the bonnets, they have dividers on the inside. They try to, you know, account for some of that, and those really help really good. There's a whole bunch of different ones, but you know, if you think about it, when you turn it to the side, now you've got air rushing through and it's coming through and it's coming back over here more, then, you know, a lot of people would say automatically, okay, well that's going to be lean because it's going through here, but that's not necessarily true. These boosters, remember how the boosters work, they work on the basis of airflow going through this venturi. So the more air you have going through this venturi, the more fuel it's going to pull. So it could be that it's pulling a bunch of fuel over here on this side, saturating this side of the motor with fuel, and then you get into a hydraulicing possible situation, especially if you're on methanol or E85. You know, that those could be problems, you know, potentially, but you know, and even the same thing could happen when you turn it, you know, forward or backwards. But from what I saw, running it forward or backwards was always better. So the next thing, so this thing's completely apart. So what you're doing is the next thing is you're going to take your bowl here, and you're going to order yourself some solid floats. And these are nitro fuel. They're very lightweight, but they're solid. And so think about it. So you got boost coming in. It's pressurizing these bowls here. It's pressurizing the bowls. It's coming down in, and that's what's helping the fuel flow. So it's pressurized. So if you have the old brass floats or the plastic floats, you know, those things have problems over time. They develop leaks and they sink, and then you get some fueling problems when that happens. So you always want to get the black nitro fuel floats. These are the ones for the back of the carburetor where you run a jet extension, and you can always tell that just simply based on, you know, they got these notches for the jet extensions. And so you always want to get those. Next thing, if you're on gasoline, you're going to want to have probably a 130 or 150 needle and seat. That's the orifice size. BLP is one of the companies I used to buy a lot of stuff from, and they have lots of good products. So, you know, go on their website. Get yourself some jet extensions. Now the jet extensions, there's a couple different kinds. These are the screw-in type. This would screw in here, and then the jet would screw in there. We found that was a problem, and if you think about it, it makes sense, because this is the restriction in the jet, is that hole. So if you put this long restricted, now that hole is pretty big, but it's not super big. So if you put the further this is, the more draw it's got to have on the booster to get the fuel out. So you always want to get the ones that we had the best luck, the plastic ones or the steel ones that slid over top of the jet here. And it was super easy to do, nothing to it. So that's your jet extension. So go ahead and grab you some jet extensions as well. So we got the bowls done. Now, if you're on methanol or if you're on E85, there comes a point somewhere in your life where you're going to need a dual needle and seat. And there's a couple different companies that are making them now: Quick Fuel, Superior, Airflow. There's a whole bunch of them out there making them now. There used to only be one or two, but basically what it is, instead of having one needle and seat, you still got one inlet for fuel coming in, but you have dual needle and seat. So you have either dual 130s, or dual 150 needle and seats, and so the volume of fuel is better, and the bowl is bigger too, so it holds more fuel. And they have individual floats. They're pretty neat, pretty cool. I'll link to you know, where you can get those at too on there. So that takes care of the bowls. So now let's go to the we'll go ahead and go to the metering blocks. So we talked about metering blocks a little bit front and back. You know, you got your power valve channel restrictor circuit down in here. So a lot of times what people used to do is just up to jets, and that was it. There are some people, what we did forever, what we would do is just take epoxy and completely fill this emulsion circuit. And what that does is when you fill that emulsion circuit, it just doesn't get any, basically it doesn't get any air from the high-speed air bleeds, and it creates, it's like we talked about earlier in the other videos, when you have a straw with a hole in it, it takes more suction to get the fuel out versus, you know, if the straw does not have a hole. You've all done that before. You kink the straw up, got a little crack in it, and you don't get as much fuel. You get the bubbles. There's a couple different theories on that. These are adjustable. Some metering blocks you can buy aftermarket, and they've got adjustability in each one of these, and you can tailor the fuel curve. The natural tendency of a carburetor is to run rich at high RPM. So what that does is, basically, that's what we want it to do on the blow through. You want it to be richer to compensate for the boost. So you can go to McMaster-Carr or Granger and get the small brass set screws. I think like 440 and 632, 832, 1032. And you can use those in various orifices in the metering block here. So you drill it out, tap it, and then drill the set screw to the diameter you want. A lot of people open up these PCVR channels to about 3/32 of an inch. And so that's real easy with the brass inserts. So the other thing you need to do, that you need to think about, is it's really easy to do. You want to drill these things out. You don't have to mess with this channel here. The outside freeze plugs are for your idle circuit, so you don't have to mess with that one. It's this one right here with your main. So basically you can use self-tappers. That's what I use down in here. Down in there, it's real simple. You take a self-tapping screw, you know, 6 or 8, whatever size it is, so you don't damage on the outside. You screw the self-tapper in there, lock a pair of vice grips on the head, and smack it with a hammer, and 4 or 5 smacks, and this thing usually pops right out. Now this next part is what messes people up. It gets people a little anxious, I guess. But you know, just remember, I mean, metering blocks are cheap, so if you screw it up, it's easy to fix it. You just throw it in the trash and you buy another one. And that's what I done. So some of the old alcohol guys, what they used to do, you get a carburetor, they got bigger jets. The actual jet thread is about twice that size. It's actually the next size up, whatever it is, but you can get really big jets. So what the old alcohol guys would do is they would take these out and they would drill these to 250 thousandths. So a 1/4 inch drill bit. You know, obviously if you can put this up in a lathe or a drill press, you know, that's better. I have done it just sitting on a table like this carefully. Now, occasionally it'll break through, and where it'll break through is on this side over here because there's not much material here, you can see. And you can see how these are facing this way more, so they're more on this side of the block. So there's a couple theories. I mean, the professional carburetor companies, you know, it's all their secret stuff. But what I generally ended up doing that worked good on the last few times I've done blow-through carburetors is I would go 180 thousandths. And so I would you know, pop these out 180 thousandths down. You can buy these little plugs from BLP, and that's all these are, is replacement small freeze plugs, and they just pop down in there. I can't believe I still got some of these left. Or the other thing, it's got to be, you know, it's got to be flush with the top of this so that it can go under the base here. But you can drill and tap this too. So you could drill it and put a 1/8 inch pipe tap. It does need to be a or a 1/16 pipe tap. I can't remember what size it was, but it needs to be a pipe tap up here in the top because it's got to seal fully. So drill the main wells out to 180 thousandths, and then you'll come over here on these cross channels and do them either 160 or 180 as well. And the reason, you know, at 250 here, think about it, if you have a great big straw, using the straw analogy again, if you got a great big straw, it takes more suction to get the fluid, the fuel, up through the straw. So if it's too small, then it's a problem because it's a restriction. So it's really one of those things you got to play with the size and the diameter of the main wells and this side port here. So the other thing you have to be careful of is when you're getting boosters. So down leg boosters, I run down leg boosters for a long time in carburetors that were blow through, and they worked okay, but they weren't great. There again, I went to BLP. I called them up. I told them what I was doing, E85 or methanol, and I wanted to put annular boosters in it. So they actually made them up. They have billet inserts, and they have the banjos, and then basically, you know, they press them all together, whatever they think is the best spec. So they have different internal orifices. So the bigger the internal orifice is here, generally the more fuel is going to flow. And the reason why is because more fuel is going through the booster. So if this is bigger, more air is going through it, so more fuel is going to get pulled down into the carburetor. So it's always interesting, you know, playing with that stuff. They have 12-hole discharge. They have, you know, 16-hole discharge. They have a whole different ones, and they play with the size of it. That's way above my head as far as what's going to work the best. That's why I would call them and do it. Now, then you got to, okay, well, I got to put the boosters in. They sell this swedge tool, and this thing's pretty easy. And these things are made out of aluminum. And you can buy a complete kit from them. If you're going to do multiples, that's a good idea. But if you're only going to do one or two, I mean, I got by with this forever. I made this little thing right here. This was my booster holding tool. It was very redneck, but it worked. It will not work on this one because this piece here is too high. But basically what I would do is this would slide down. So if you can imagine, if this divider was not here, it would slide down, and then I would just open these up. And it would basically just have a booster on that side and a booster on this side, and that would be the tool that held it in place. And there's a couple different ways you could do it, but the booster needs to be centered. It needs to be in the right location. This is a very redneck way to do it, but then basically this goes in the drill press, and then I always put WD-40 on it, and it just spins it. And basically, all you do is this thing just, it goes down in there, and you can see it's at a taper, and you can see this is tapered down in there as well. So all it does is just go in there and pops it, and when that thing gets close to the bottom and out, you're done. So now the booster is installed. Now you have to be careful, you know, you don't want the booster to be loose, I mean, but it swedges it out. All it does is it makes it like a funnel out there. So now you got your boosters. The boosters may be a little challenging for some of y'all. So I mean, you know, if you don't want to do the boosters, like I said, you can definitely get by with the down legs for a little while. Straight legs, you can actually take a straight leg booster and drill it out just a little bit to make it a little larger. But you know, it becomes problematic at some point. You can also buy center sections. Another carburetor I had good luck with a center section. It was the Proform center section, and I'm sure BLP sells them also, but it had annular boosters already installed. And when you order it, especially like if you get them from BLP or somebody, there again, you tell the leg size what it needs to be, and then you match the leg up. So if this was 160, I would make this 160 as well. And I probably would still do 180s down here. I mean, I guess you probably, I mean, in theory, you could go, you know, 160 here, 160 here, and then 160 down into the main well here. And so, like I was saying, I mean, you know, we started, you know, messing with blow-through carburetors a long time ago, and there was only a few people. That was back in the very, very beginning. CNS was doing a few. CSU had just come on the scene, and Kevin was doing a bunch, and he was really good, and you know, he was, you know, taking leaps and bounds in the world of blow-through carburetor. But so that's how you can modify your own metering blocks though. So generally, if you had a 650 or 750 carburetor, you know, you would up the size in the jets just a little bit. I'll tell you, go about 5 numbers bigger on the front, and about probably 10 on the back, on the secondary side. But then you would also take this PVCR channel out just a little bit bigger. And every carburetor is different. Some of them are 60 thousandths, some of them are, you know, 70, 80 thousandths. 330 seconds is a number that we used to use a bunch. Get your high flow power valve in there, you know, and then it just works like a champ. I went decently fast with a stock metering block, and all I did was go in here and just epoxy that up, and it was fine. It run halfway decent. But you know, once we get to a certain power level, then you start having to open everything up, and I don't know what that power level is. I don't remember. It's been a long time since I've done it. Now, if you have a very slow spooling turbo, That was a problem that we had for a long time. And then Kevin, I think Kevin was the first one to create the boost reference power valve over at CSU. And so, you know, that opened on boost instead of vacuum. Spring held it shut, and then boost pressure hit, and then it opened. So one of the big things also with blow-through carburetors, and this is something that you see almost everybody do it now. Some people used to take these vent tube extensions off just so that, you know, they said it didn't matter. And I mean, you know, there's a whole bunch of different things, whole bunch of different theories. Some people had these, you know, cut down low. Some of these are slash cut. See how this is slash cut, nice and neat. So at some point, I was sitting on my porch. I was messing with my blow-through carburetor. And Brent Davis, he was Red Mustang on Turbo Mustangs back in the day. He was honestly probably one of the premier guys that was a do-it-yourselfer that was doing blow-through carburetors. Kevin was helping him some. The phone rang, it was Brent, and I was like, "What's up, man?" And he was like, "Dude, I just found the solution to making the carburetors work better." And I was like, "Really?" And he was going to share the information with me, and he did. And that shared information was the vent tube extensions. And it makes sense when you think about it. So, and it was going off of airspeed tubes that are in aircrafts. I don't even know how to pronounce it. P-I-T-O-T, I think. Pitot tubes. Pico. But anyway, that's how you check it. They come over, and I would always hose clamp them together. And real close to the edge of the bonnet is where I would try to get it. So if the bonnet come to here, I would try to have the tubes like right here, and they would usually be stacked on top of each other. And so this would increase as boost pressure increased by aiming those into the stream of air, into the boost. You were able to drastically reduce the jet size. And so it made it much more drivable. It made it much better coming up on boost. It made it so that it was just more user-friendly all the way around. And then when boost come, the air started cramming in those tubes. And so now you've got a pressure differential that is higher. You got more boost pressure, if that makes sense. I mean, because it's in the stream of air in the bowls. And so now the pressure is a little higher in the bowl than it is here. And it just makes the fuel flow better. It just gradually makes it richer. It makes it so that it works better. At that point, okay, well, this is a tool that we can use to tune with. And that was 100% correct. So then you start messing with the slash cuts. So if you made this more of a slash and taller to the top of the bonnet, then it gave you more fuel, but not as much as the tube that is, you know, the one that vent tube extension that's real long. And so it's a tuning tool, how high it was, and, you know, the sharpness, the angle of these vent tube extensions. So that was amazing. That was a critical point in the tuning process there, and how to make this stuff work. And so basically, you know, you just grab these with a pair of pliers, and they usually spin out and pull up, and then you can turn it whichever way you wanted to. And so you'd always have them facing the same way. And then that way, you know, you got the air pressure. So, I mean, it was pretty easy. It's pretty simple. Tube extensions was huge. That was huge. So, we got our solid floats. We got our modified metering blocks. We got our vent tube extensions. You got your good bonnet. What I would recommend on bonnets, too, you know, there's some out there. I know you got hood issues. But if you've got a bonnet that's only about 2 inches tall, you're going to get terrible carb performance. And it's just, there again, if air is lazy, it's going to try to go straight. It's not going to try to turn. So it generally doesn't work as well. And you get distribution issues and some erratic, you know, things on the way the carburetor behaves. So the taller you can get it, and even if you could put a spacer on it to where it's just like in the EFI world, I mean, the higher it is, the more the air has time to straighten out, the better the carburetor is going to behave. Now, I went really fast with that little $80 Spectra. It run really good, and I eventually went to a, you know, the really good expensive Pro bonnet, and I didn't really see a ton of horsepower difference, but what I did see was better distribution from cylinder to cylinder. So that was a big thing. So flipping over on the carburetor here, you know, one of the things, some of these, a lot of them don't even have them, or they're already knocked out. But some carburetors have in the very bottom down here, there's a hole. It's a power valve protection circuit. And what it does is it's basically designed, if you have a backfire naturally aspirated, the ball protects the power valve so that the power valve doesn't get blown. But in a boosted application, this could really work against us. We don't want that valve to shut. So you want to make sure you just disable that check valve and get it out of there. So depending on what type of fuel you're on, if you're on E85 or if you're on methanol, you definitely want to increase the capacity of the squirter bowl here. These are 30 cc's, 50 cc is the next one up. Make sure when you're adjusting this, there should be no slack right here in between the spring, the nut, and the arm. You always want it so that it instantly moves as soon as you move it just a little bit. So that's kind of the basics on a blow-through carburetor. It works, it's cheap, it's easy. You need a wide band. You got to have a wide band in order to do the blow-through stuff. You got to be able to, I mean, you can tune by the plugs, you can tune by EGT. I've done it forever. EGT will kind of fool you around sometimes. If your timing's too low, you know, it'll give you a high EGT and you start going the wrong way. You start thinking, okay, well, it's lean. You start throwing more fuel to it, and then it just gets worse. So, you know, wideband is good. I used to run the old LM1, and it worked great. The LM2, I assume it works good too. There are some, you know, other standalone widebands now. But by the time, you know, you get your carburetor done, you get your boosters, you get your metering blocks done, you get your $500 needle and seat bowls, dual needle and seat bowls, you get your wideband, you get a whole bunch of stuff to make the blow-through carburetor, you know, to where you can get data on it. You're not far off from EFI. And so it's one of those things you just got to, you know, consider. You got to think about it. You know, everybody automatically, you know, will blow-through carburetor is super cheap. You know, carburetor itself is pretty cheap normally. I mean, but you know, you can, if you go to CSU's website or CNS, you know, or any of those other big companies, I mean, blow-through carburetors are, I mean, they can be expensive. I mean, but they do all the work. They make them, you know, right so that it's just a plug and play deal on your car. But then when you start getting I need the data, you know, I need the wideband, I need, you know, to be able to see more information. You know, by the time you spend money on a race pack, I mean, in my opinion, EFI is, you know, definitely the way to go. But that's it. That's your basics of blow-through. All right, guys. Well, that's the basics of the blow-through carburetor. If you're on a budget and you want to do it yourself, you can. But here's some of the things you need to know. Y'all comment, like, and subscribe. We'll see y'all next time. Thanks.